In advanced FinFET nodes, analog layout has become significantly more challenging due to the strict and discrete nature of design rules. Unlike planar technologies, both OD spacing and vertical width must follow specific discrete equations. Additionally, poly width and spacing must often comply with discrete poly pitches. These constraints make manual placement difficult, error-prone, and time-consuming. Even minor misalignments can trigger DRC violations early in the layout stage, leading to significant debugging efforts later in the design flow. To address these challenges, we offer the FinFET Grid feature, a powerful capability to help designers mitigate DRC errors directly during placement. By embedding FinFET-specific intelligence into LEDit, this feature ensures DRC-clean placement by construction. I'm Latifa Regragui from Siemens Product Management for the custom IC design environment, and in this video, I will show you how to work with the FinFET Grid in LEDit. The key benefit is snapping. With the FinFET Grid enabled, shapes automatically snap to valid grid locations. This behavior is not limited simply to shapes. Instances and standard cells also snap correctly, ensuring they align perfectly with the process constraints. Even hierarchical blocks can be snapped consistently, making it easier to maintain rule compliance across all levels of the design. Furthermore, editing commands are fully grid compliant. If we move an object, it remains aligned to the grid, significantly reducing the risk of DRC issues related to placement and boosting the overall productivity. Another important capability is that LEDit supports both global and local grid definitions. The global grid provides a consistent placement framework across the entire design for uniform alignment, while the local grid gives designers the flexibility to adapt snapping behavior to specific regions or contexts where extra control is needed. Together, these options provide the perfect balance between design consistency and local flexibility. LEDit also supports 2D snapping, which is critical in FinFET design. So rather than aligning objects in only one direction, 2D snapping ensures valid positioning in both dimensions. This helps designers satisfy the tight constraints for both poly and OD layers simultaneously, making placement more intuitive and further reducing the chance of violations. Concerning the setup of FinFET Grid, all FinFET PDKs supported by the Siemens PDK enablement team include these grid setups by default. And to visualize the FinFET Grid setup, first list filter out FinFET regions and open the layer setup dialog for any of these listed layers. In the FinFET tab, we can view the grid parameters including direction, step, and offset, and this table lists the layer that snap to this specific grid according to their specified enclosures. We can also define a new local FinFET grid by selecting its boundary layer and entering the grid parameters in the FinFET tab. LEDit also provides flexible display options, enabling designers to customize how FinFET Grid is rendered. So snapping is controlled through the Enable FinGate snapping button, and if you happen to edit your design while snapping is disabled, don't worry. Simply turn the button back on and use Convert Snap to Grid to instantly align any off-grid objects.